Well, hello everyone. Welcome to my GCSE Maths video. Today I'm going to be doing my video on surds. I'm going to try and teach you a little bit about surds and give you some understanding of what's going on with them. And then I'm going to show you some questions, including past exam questions from Edexcel. Okay? This is a difficult topic, grade A at least, but usually grade A star. So let's start talking about what is a surd. Okay? A surd is something, it's a number, okay, usually, and it's written with a square root. So if you've got something like square root of 2, if you put that into your calculator, you'll get an answer of 1 point something, okay? But in maths, if we want to keep exact, we can leave it and write just square root 2. Or for short, root 2. Okay, another example of a surd would be root 3. Now we have rules that we can use with these special types of numbers, okay, to simplify and to combine them together. Now before I talk to you about those rules, I want to do a brief reminder about something in brackets to a power, say squared. So if you've got x times y squared, what you need to do is you need to think the squared is doing it to everything. So you square y and you square x. Okay? So that means if you do the whole thing to the power of 2, it's the same as each thing individually to that power of 2. Okay? Another example might be if you've got wm to the power of 4, that means you've got w to the power of 4 times m to the power of 4. And basically our surd rules are built around this concept. So let me show you what I mean about our surd rules. If you've got the square root of x, another way to write that is x to the power of a half. If you get your calculator and you type in square root of 9 using the square root button, then you're going to get 3. If you get your calculator and you type in 9 to the power of a half, okay, you're going to get the same answer, 3. This is the key thing I want you to know. They mean the same thing. Okay? So that means, I bet with a bit of convincing I could persuade you that if we've got x times y to the power of a half, that's the same as having x to the power of a half times y to the power of a half, because it is the same rule as before. It just so happens that the power's different. Okay, the same rule we've already applied. Now what if we weren't writing the power as a half? What if we were writing it like the square root of x times y? Because that's the same thing. Well, that means you would have the square root of x times the square root of y. And it's quite nice to think of this with a couple of examples. Okay? So, e.g., if we want to know, let's do numbers we already know about. So let's do a square root of 9 times the square root of, I don't know, 16. Don't want to make this too complicated. Right, if we multiply square root of 9, which is 3, by the square root of 16, which is 4, we get 12. Now what this means is, you can do the square root of 9 times 16. Okay, which is the square root of 9 times the square root of 16, which we've already done, so I don't want to show you that same one again. 9 times 16 is actually 160, take away 16, 144. And guess what? The square root of 144 is 12. So that's a numerical example of the rule I've just explained. If you've got two numbers multiplied together and square root each one, it's the same as the square root of those two numbers times together. Okay, very, very important third rule. So we can write that the square root of a times the square root of b equals the square root of a times b. Okay? Now let's say that you started with the square root of 125. You might think, square root of 125, don't think I can do that. And you need to get really good at recognizing when your square numbers come up. Okay? So you might be thinking, is there any two numbers that I can times to make 125 where one of them is a square number? And the answer is 25 is a square number that goes into 125. What do you have to times 25 by? Well, 3. Because of our third rules, the square root of 125 equals the square root of 25 times 3. We can split that up into the square root of 25 times the square root of 3. The square root of 25 is 5. So the answer, as a third, is 5 root 3. When your exam question says leave your answer as a third, okay, it's allowed to have square roots in. Do not start putting it into your calculator and getting a decimal. That's not what it's all about. In maths, it's sometimes nice to just write 5 root 3, which is what our answer is to the square root of 125. It's a little bit like simplifying fractions. You wouldn't leave a fraction as 8 over 16. You would generally divide by 8 and put it as a half. It's very much like that. You wouldn't leave a third the square root of 125. You would simplify and write 5 root 3. Okay? That's called simplifying surds. There are more things that you can do to surds, and I will talk to you a bit more about these, but surds are just numbers, so they work very, very much like numbers. One thing that you need to know is if you've got the square root of, say, I don't know, 3. If you times it by itself, okay, the definition of square root is what the number that times us by itself to give you this. So if you actually go ahead and times it by itself, you're going to get the number. Okay, so as an algebraic rule for you, square root of a times the square root of a equals a. If you love your algebra, you could think about that as square root of a squared, a times a. Okay, and then the squared and the square root cancel each other out. Same thing again. So that's another rule for you. I've shown you 2 so far. I want to get on with the questions now, and I will talk you through some stuff at the same time. Write down the value of 49 to the power of a half. Remember that I said power of a half is another way to write square root. So this just means the square root of 49. So what times us by itself to make 49? 7. That's why it's just write it down. You do need to know your times tables. Write the square root of 45 in the form k root 5. This is an A-level like question. What it wants you to do is get a number value for k. Okay? We're just going to apply our third rules to this. Okay? So you need to think, how can you split up 45 and get a square number times something else? And the trick is, you need to get the biggest square number you can. Okay? The answer to a square number that goes into 45 is 9. What do you have to times it by? 5. Because of our third laws, the square root of 45, okay, it can be written as 9 times 5, and that is the same. Excuse me. It's the square root of 9 times the square root of 5. Now your aim is to get square roots that you can actually figure out. Remember, square root means what times us by itself to get it. What times us by itself to get 9? The answer is 3. Okay. Next one. I told you we can apply these surds like normal numbers. Okay. We know the algebra of expanding brackets. I've done a video on this called the banana method. Okay. So we just apply our same rules. The only difference is we're going to have a couple of things to do with surds in there as well. So the first one, 2 times 2 is 4. The next one, 2 times root 3, and it's a negative. Okay, don't mean to make that look like an equals. So minus 2 root 3. The next one, plus 2 root 3. The next one is minus root 3 times root 3. Okay, now we have to simplify. Simplest form, look. So 4 can wait there for us. Here we've got 2 root 3, and then we take away 2 root 3. So they cancel out. Got nothing left from that. Now we've got root 3 times by root 3. Okay, so the very thing that times us by itself to give you 3, and guess what? It's being times by itself. So you're going to get the answer of 3. And it's a takeaway here. So the answer is just 1. And you might think that's ludicrous. That means that this thing here in the purple box is another way to write 1. I could tell you many, many ways to write 1. Okay? Probably infinite ways, in fact. But the fact is, this GCSE question is testing your surd rules and that you know how to expand a bracket. Okay? And you should be pleased when you get to quite a simple answer. Right, next one. Expand and simplify. Root 3 plus root 15 squared. That means times by itself. So I'm going to do another bracket because it's a whole thing times by itself. Okay? Give your answer in the form a number plus another number times by root 5. Okay, integers just means whole numbers. So if you don't get a whole number, something has gone wrong. Let's times out using our banana method. Root 3 times root 3. I'll simplify in a minute. Root 3 times root 3. Okay, next one. Root 3 times root 15. Root 3, root 15. And it's a plus. Next one. Root 15 times root 3. Doesn't matter which way around we times it. Okay, so I would write it with the root 3 first, because root 3 is smaller. And it's plus again. And then root 15 times root 15. Okay. Now remember what I said. The actual example I gave you at the start has come up twice already. The square root of something times by itself just gives you the number under the square root, so it's 3. Here, can you spot the difference or spot the similarities? We've got 2 of this thing here. We've got it twice. Okay, you've got 1 here and you've got 1 here. So we're going to put them together and say we've got 2 of them. Okay. And it's plus. And then at the end, we've got the square root of 15 times by itself, so that just gives us 15. Right. Now look, it wants a root 5 in there somewhere. So we're going to have to do a bit of trickery here. Now, remember what I said before about surds? If we wanted to, we could combine those 2 things together. Okay? Or, both ways would work, we could just focus on the square root of 15 and think, wouldn't it be nice if we had another square root of 3 to go with this one? They could be friends and they could combine together to make an actual whole number, the whole number 3. So we split 15 into 3 and times 5. Okay, and because of the surd rules, square root of 3 times 5 is the square root of 3 times the square root of 5. This root 3 has now got a new friend. This 3 and this 2 lots of it stays the same. Add the 15. Now remember, when you've got root 3 times root 3 together, they team up, okay, and you just get the 3 out of it. So this is, instead of root 3 times root 3, it's just 3. Remember, these are, when we're putting things next to each other, it's all invisible time signs, okay? All the time. All invisible multiplies. So, there's a multiply there, so what we're actually thinking about is 2 times 3 times root 5. And by the way, I'm going to put 15 and 3 together to get 18. Okay, 2 times 3 gives you 6, and it's times by root 5. We've done it. We've got a number plus another number times by root 5. Okay, brilliant. Another expansion of brackets. 2 plus root 3 times by 1 plus root 3. Okay, so we use the banana method again. And we expand each one. I'll speed up a little bit now. So 2 root 3, 1 root 3, you can just write root 3. Root 3 times root 3, I'm going to go straight, if you don't mind, to 3. I know that when you times the square root 3 by itself, you get 3. So, combining like terms, 2 plus 3 is 5. And here you've got 2 root 3 and another root 3. So guess how many you've got? 3 root 3. Look what the question asked for. A number plus another number times root 3. That's what we've got again. Rationalise. This is where it can get a little bit tricky. Now, if you're given something in maths, as long as you don't change what it is, you can do extra stuff to it. So for example, if I really wanted to, I could add on 0 to this because it's not going to change it. But what would be really nice is if I could do something that would help me simplify it. I could times by 1. Okay, that doesn't really do much good. But if I think that this is a fraction, and rationalise means you want a rational number on the bottom of a fraction. Okay, that means that you want to get rid of this square root of the denominator. Now, how do we get rid of a square root if we've got square root 7? You can times by square root 7, because that's just going to give you 7, remember? Okay, so if we could times by the bottom by root 7, that would be really cool. Okay, but we can't just change the equation, so we need to times by the top by root 7 as well. And look about the cool thing of maths. The number divided by itself is 1. So all we're doing is timesing it by 1. That's why you're always told do the same to the top and the same to the bottom. So we get 1 times root 7 is root 7. And root 7 times root 7 is just 7. Okay, so that's it done. You can check all these on your calculator, of course, but these will probably be non-calculator questions, I'm afraid. Express 6 over root 2 in the form a times root b. Positive integers, whole numbers. So notice there's no square roots on the bottom of this, so we need to get rid of this root 2. So we're going to times by root 2 over root 2, so we're not messing anything up. On the top, 6 root 2. Root 2 times root 2 is 2. Okay, so you've got 6 times root 2 on the top, and then you're dividing by 2. Well, you can just focus, and you can just divide the 6 by the 2, which gives you the answer of 3 root 2. Okay. This is a tricky one now. Root 18 plus 10 over root 2. Okay, we want to rationalize the denominator because you can see from the question we want a number plus another number times root 2. So there's no root 2's on the bottom. There's not even a bottom of your fraction. So I'm going to times that whole thing by root 2 over root 2. Now it doesn't matter where you multiply by 1. You can multiply it on the front or at the end. It makes no difference. I'm going to do it at the front, and the reason will become clear very soon. Now, if we're multiplying by this, we want to multiply everything on the top by it. Okay? So that means that we're going to need a bracket. So we need a bracket here. That's going to give us root 2, root 18 plus 10. And on the bottom, root 2 times root 2 over 2. Now we expand our single bracket, half a banana. Root 2 times root 18. Okay, let me just write it out like that first, then we'll simplify. Plus root 2 times 10. Just like with algebra, you wouldn't write, you can think of this as an x really. In algebra, you wouldn't write x10. It means the same, but you just write 10x, don't you? Okay, it's better, you all know that. So we're dividing that by 2. Let me talk about this thing at the front. Okay? Third rules. Square root of 2 times the square root of 18. Okay, you can put them together, times them, you get the square root of 36. Root 2 over 10. 2. You might all be shouting at your screen now. I know what the square root of 36 is. Always be looking out for the ones that you know. You know that 6 times 6 is 36. So that means that the numbers that multiply together to give you 36 are 6. So that's going to be 6. We're dividing by 2, so we need to divide this by 2 and this by 2. So it's going to be 3 plus 5 root 2. And as usual, we've got it in the desired form, so we've got it right. Okay, tricky question here. 5 plus root 3, 5 minus root 3. Those of you really good at algebra will be spotting that this is going to cancel out in a nice way. Okay, but I'll show you what I mean in a second by that. Just multiply out the top. What I've just talked about briefly says that 5 times root 3 with a negative, 5 times root 3 with a plus. Those two multipliers are going to cancel out. Only because the numbers in the bracket are exactly the same. It's just a sign that's different. So I'm going to do a little shortcut. I'm just going to do 5 times 5 is 25. Root 3 times root 3 is 3. And it's a minus. It's all over root 22. Okay? So, on the top we get 22, on the bottom we've got root 22 waiting for us. We have to rationalise this. Simplest form is asked for. Okay, so we're going to multiply top and bottom by root 22. So on the top we get 22 root 22. On the bottom, root 22 times root 22 is just 22. This is a really cool thing here, that the 22 on the top, the 22 on the bottom, are going to cancel and just leave you with the answer of root 22. So yet again, a very strange way of writing something quite simple. Okay. Rationalise the denominator again. 5 over root 2, you should know the trick by now. Multiply by root 2 over root 2, and you get 5 root 2 over 2. We've rationalised the denominator, Okay, that is not a surd, that is just a number, just an integer, so it's fine. Next one, 2 plus root 3 squared, that means times by itself. Take away 2 minus root 3 squared, which means times that by itself. Banana method on the first one, we're going to get 4 plus 2 root 3 plus 2 root 3. Again, you might be able to do this quicker in your head. Plus root 3 times root 3, which is 3. Be careful here. Take away all of this stuff. Anything we get as a result from here is all taken away because of that minus. Okay, so we get 2 times 2 is 4. 2 times root 3 and it's a negative. 2 times root 3 and it's a negative. And negative times a negative is a plus. Root 3 times root 3, don't know how many times we've said it, is 3. So let's simplify now. We've got 2 root 3 plus 2 root 3, it's 4 lots of root 3. And we've got 3 plus 4 is 7. Okay, now let's take away all this stuff. Let's simplify what's in the middle. Minus 2 root 3 minus another 2 root 3 minus 4 root 3. Okay, and the other things that we've got is the numbers 4 and 3, 7. So, this is where people might make mistakes. This is effectively a minus 1 in front here. We have to times in the negative. So let's do that now in this step. Minus 7, 1 times 7 is 7, and it's negative. Minus 1 times this, well, it's a minus times a minus, so this becomes a plus 4 root 3. Can you see your minus 7, your plus 7 are going to cancel, and you've got 4 root 3 plus 4 root 3, 2 4 root 3, 2 times 4 root 3, 8 root 3 is your answer there. Okay, quite a cool question. Right, that's all I wanted to show you then. So hopefully that's helped you with surds. This was for someone who asked for it. I'll always try and give it a go and give you what you need for your revision. My aim, guys, is to help you achieve maths. I hope I'm doing that. Okay, I really hope you achieve your full potential. Good luck in your revision. Thanks for watching.